Okay, so metals are in solid state most of the time. Can you tell me exceptions to that?
Solid state is mercury. The exception is mercury for the first one.
Okay. So mercury is liquid at room temperature. Very good. Akshat, do you want to say something?
No, sorry. I forgot one.
All right. Atoms in atoms in metals are very closely packed together and have a special type of bond known as metallic bond. And this is metallic bond. Okay. So what does it mean when I say atoms are very closely packed? In comparison to, let's say, water, are atoms in water? Well, that's not even an element. I mean, it's a molecule. Let me give you another. Okay, yeah. So even inside water, can you say all the atoms are very closely packed in water?
No, ma'am.
Okay, so what does it mean when I say atoms are very closely packed? What does that mean?
It's solid.
It's solid, yes, but not all solids are metals, right?
Yeah, that's true.
Yeah, so then what is it, what does that mean when I say that there is metallic bond? What does that mean? Can you guess? All right, so let me give you an example. So can you tell me what does it mean when I say metals share a metallic bond? What does that mean? Or whether, yeah.
Some attraction.
That means most metals, they share like a similar type of atomic structure. That's just my guess. It's just a guess.
Yes, actually most metals do share a similar type of atomic structure, but and you are partially right, but not entirely. So
that's why I said similar.
Okay, so then, all right, fine, I'll give you that. All right, so let's take, for example, aluminum, okay? Can you guys tell me the atomic number for aluminum? Okay, let's not use aluminum. Okay, fine, that's fine. Let's use aluminum, no issues. All right, so 13. Okay, so can you, if the atomic number for aluminum is, so what is the electronic configuration? 283. Okay, very good. Does everybody know what electronic configuration is?
Yeah, you like divided into three shells which have a certain maximum number of atoms they can take. Atoms or whatever. See, like 13. So the maximum of the first shell is 2. The second shell maximum is 8. The third one is actually 8.
Okay, so so I'm going to explain electronic configuration very briefly because not everybody is aware of it. So electronic configuration is basically how you divide the number of electrons in an element, okay? So basically you have this nucleus in an atom. For example, I take hydrogen atom, okay? The hydrogen atom has one proton and one electron, all right? So this is the nucleus has the protons and there is one electron going around the nucleus. So the electronic configuration for this will be 1. Okay. Now, if I write lithium, for example, lithium has an atomic number of 3. Atomic number represents the number of atoms. Sorry, number of protons inside an atom. So if I say atomic number of lithium is 3, that means there will be 3 protons inside the nucleus and 3 neutrons as well. Okay. So in this case, there are 3 neutrons. Now, the first shell has a capacity of only 2 electrons. It cannot take more than 2 electrons. So the third electron goes into the second shell. All right. So the electronic configuration of this will be 2, 1 or 2/1. Okay. However you write, you can write it whichever way you want. Okay. 2/1. Now, if I take, for example, neon, okay? So neon atomic number is 10. So that means it has 10 protons. I'm just going to put 10 protons over here. And how many electrons will that have? Again, 10 electrons. So 2 electrons in the innermost shell, because it cannot take more than 2. The electrons start filling after that. So the second shell will have 8 electrons. 4, 5, 6, 7, 8. All right, so this is the second shell. It has 8 electrons. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally I have 10 electrons. Now if I go from neon, if I go to, let's say, magnesium. Magnesium has atomic number 12. So what happens, oh, by the way, the electronic configuration of neon is 2/8. 2 electrons in the inner shell, 8 electrons in the second shell. For magnesium, it is 2, 8, 2, because the second shell cannot take more than 8 electrons. So once the 8 electrons are filled inside the second shell, it goes into the third shell. Okay, it starts filling into third shell. So 2 plus 8, you have 10 electrons. There's 2 more remaining, so those go into the third shell. Is this clear to everybody?
Ma'am, I have a doubt.
Yes.
Why do these shells have a maximum number? Like the
Very
first
good.
shell?
So the reason that they have a maximum number is because each of these shell has some amount of energy associated with it, okay? And also when you put electrons inside shells, electrons are negatively charged. And what happens when you have negative charges, you bring them close together, what happens? Similar charges, when you bring them close together, what happens?
They repel.
They repel, yes. So when like charges are got close to each other, they repel. All right. So because of that, also the orbits or the shells have particular sizes to them, right? So if you try to put in more than the number, you know, that it can take into it, then those electrons don't have the space to go around in that case and also keep that force of repulsion between each other. Does that make sense? So like the further out I go from the nucleus, the more space the electron has. Kind of like, you know, the planets in the solar system, right? Mercury has a smaller orbit because it is close to the sun. The further away I move from the sun, the radius of the orbit increases. And then I can put in some more planets, or not planets, technically that would just ruin everything, but like electrons in place of that. Does that make sense? Okay, so the atomic number of aluminum is 13 and the electronic configuration of aluminum is 283. Okay, now how many free electrons does this have, or how many valence electrons does this have? What is the atomic number of neon? Do you know the atomic numbers?
Ma'am, we didn't study it.
Okay, you did not study the atomic numbers. Okay, fine. So this is something that you absolutely need to know. Okay, so if you don't know that, you will not be able to understand or know the electronic configuration. So just make sure for the next class you study atomic, or you remember the atomic numbers for elements from 1 to 20. Okay.
Yes, ma'am.
All right. So in the next class, when you're done with this, maybe I can stay back after the class for some time, and then I can teach you what electronic configuration is. Okay?
Okay, ma'am.
All right. So yeah. So aluminum has +3. So it has 283, right? So that means these 3 electrons are free. Okay? And so what does that mean? That means if, let's say, I have an aluminum table, okay, this table is made out of aluminum. Inside this table, I have atoms of aluminum. Okay, let's say this is the surface of the table. All right, so if I say this is the surface of the table, this is the legs of the table. And now this table has atoms of aluminum all throughout. Now each of these atoms will have 3 free electrons. So these 3 free electrons are over here for each of these atoms. Now, these electrons are kind of like, they keep going. It's like this ocean of electrons, ocean of 3 free electrons coming from each and every single atom of aluminum in that aluminum table. And that is why these metals are conductors of electricity, because they have this free electron that is freely, these electrons are freely moving around. So these electrons, you know, because they are so close to each other, the atoms are so close to each other, that the 3 electrons from this aluminum atom goes into this aluminum atom, and this keeps on circulating in very random motion. But once you connect it to a battery, all these atoms, they align and they start, you know, completing that circuit. And then you can basically electrify this particular aluminum table. Does that make sense to you guys?
Yes, ma'am, it does.
Okay.
Ma'am, I have a doubt. I don't know if it's relevant or not,
Yeah.
but I wanted to know why don't Pacific and which ocean was that? The Pacific and some other ocean, they don't actually merge. Like one ocean, one sees oceans.
I think Atlantic.
Yeah, I guess. So Atlantic's ocean, water is like kind of green, and Pacific's is blue. Why don't they merge?
Actually, that is a chemical phenomena, and I don't have it at the top of my head right now, but it has something to do with densities.
Oh.
Basically, I was actually looking at the article a few days ago. I remember that they told the amount of trash or the amount of pollution inside the water is, I think it said this, but I think inside the water is changing the density of the 2 different types of oceans. But I still don't figure out. I still don't figure how like those 2 oceans can't merge, and there's like a clear color difference between those 2. But I feel like that's what it said. If it didn't say that, it's my fault.
I just looked it up. It says it's due to the difference in the water density of these 2 oceans, and that is because of the temperature and saltiness from the glaciers that this water melts. So the salt content and the temperature causes that difference in the density, and that is why you see that these 2 oceans, when they meet, they don't really merge. Yeah, so this is the reason why, because they all share their electrons, it becomes like a, kind of like an ocean where you have all of these atoms placed right next to each other, and they have to be so close to each other that they can share all these electrons amongst themselves. And that kind of a bonding, all of these free electrons, they have to be shared between all of these atoms, and that creates like a tight, closely packed substance.
Covalent bonds.
I would not call them covalent bonds, because, yeah, you are right. Covalent bonds are formed by sharing of electrons, but those sharing of electrons, they form what is called as the bond pair. Here, there is no bond pair. These electrons are free electrons. So I wouldn't call them covalent bonds. They are just metals. Okay?
Oh, okay, got it.
Yeah. All right. So anyway, so 70 out of 115 elements are found to be metals.